Hey everybody, Gabe Jenkins back with you. Hope you're having a great day. I know I am. I'm here to do a really kind of like fast-paced, hopefully, overview of all the sketching tools in SolidWorks. You should have a really good, solid, foundational understanding of a lot of the basic sketching tools in SolidWorks because you basically use all these same tools in AutoCAD, and they work very, very similarly to how they worked in AutoCAD as well. So I'm just going to go through some of the things with you. I'm going to highlight a couple of things. I'm going to highlight the importance of fully defining your sketch elements, your shapes, because it's going to be important when we come to try to make three-dimensional shapes out of those sketch profiles, those contours, right? That's going to be kind of the main thing I'm going to highlight. That and geometric constraints and what you can do with geometric constraints at the sketch phase, how to notice where they're there, and maybe how to change them, how to set it up, specifically with the idea that if you understand what you're trying to eventually create, using that understanding of your kind of your final expectation, your final product, to inform how you do the sketching that you're going to do. So you'll see what I mean in a second. So here we go. I'm going to go to New, Part, and again, keep in mind, I'm going to ask you some questions based on this video. So please don't just go through super fast. You might miss something that you're going to need to know. All right. So opened up a new part in SolidWorks, and same screen we saw before, and going to go through all the same steps. Remember, whenever we're going to make a new sketch, a new sketch is going to start off by picking the plane that we're going to draw on, right? Opening up a new sketch, using the sketch tools to draw elements. 4, use smart dimensioning to make sure that we've kind of fully defined those things. And then 5, once it's a closed contour, using that, hitting OK to kind of finalize that shape, and then using that shape to create some three-dimensional geometries. We're not going to worry about the three-dimensional geometries here, but certainly all those earlier steps matter. So we're going to start by drawing on any plane. I'm just going to pick the front plane. Sure, I right-clicked on front plane. Going to go to New Sketch, brings me here. We're going to start off with the most basic tool there is, the line tool. I'm going to anchor kind of my first line on the origin, because that will help me to fully define anything I draw. So I'm just going to draw this, and it works the same thing like AutoCAD, where you start, you click again, you click again. It's going to keep assuming that you want to draw a string of lines as you go. Like, it's not going to just stop until you hit escape. If you ever want to get out of it, you just hit escape and you're done. So I'm going to click here. You notice that as I kind of go near 90 degrees, it kind of locks in on 90 degrees. So just like AutoCAD kind of had us, it gave us that green light, that green line that showed us when we were at one of our kind of key angles, whether it was 90 or 45 or 30 or 60. Similar thing happens here. It kind of locks you on to 90. And you're going to say, I'm just drawing a line. I drew that first line as vertical, and you can see on my screen right there, there's a little green box with a vertical line on it. That means that one of the construction, like the geometric, the constraints the geometric constraint that it placed on that, it says it expects that line is going to stay vertical. If you don't want it to be that, you can change it, but let's just say I want it to be like that for now. So I'm just going to keep on making a few more lines. That one, I thought I wanted to make it horizontal. This one, you can see there are yellow lines that are highlighted. If I'm going to make a 45-degree angle, say I don't want to do that yet. Say I want to just kind of make it like this. You'll notice also if I hover in different spots, it can try to identify what I'm trying to relate it to. So the fact that I went over here, hovered over the origin, and then moved out to the right, it's going to assume that I want to make it, whatever I click here, it's going to assume that I want that to be equal or the same horizontal level as the origin. And now I'm going to just close it. You see that as soon as I close it, I got a closed gray shape. That means that it's a closed contour, and I could use this shape to turn it into a three-dimensional shape. Let's talk about some geometric constraints that I'm putting on here, though, right? So it assumes that this line is going to be vertical, this line is going to be horizontal, this line is going to be horizontal, and it thinks that all, like this line and this line are both going to be coincident with the origin. Meaning it's going to stay locked in on the origin. Those corners are going to be locked in just like we had in AutoCAD. We were able to lock certain things together. It's assuming that those are locked onto the origin. Now let's talk about some other stuff, right? Say I wanted this line and this line to be perpendicular, right? Okay, cool. Here's what you do. You select the line, click on it. It allows you to start to connect it or make relate it. We'll say it allows you to begin to relate it to other elements of your shape. So if I click on that, you'll notice this box over here starts to pop up with line properties. Do I want to make it horizontal? Do I want to make it vertical? Do I want to fix it right where it is? Like just say, no matter what, that line is locked into that spot. I can also change this right now to be a construction line if I wanted to. So if you want to use, this is going to become important later on if you want to just like situate elements and make sure that they are positioned correctly where you want them to be, but you don't want them to be really part of your shape. You just want them to help you locate the center points or other geometries in your shape. You can use it as a construction line. But let's say I want this one and this one to be perpendicular. I've already highlighted that one. If I hit the control button and click on this one, whoop, go back again. If I click on those two lines together, right, it then gives me a whole like little menu of things that I could do to make those connected. I could say I want them to all be horizontal. I could want them both to be vertical. Collinear. Collinear means that they would be kind of like on the same line this way, right? Perpendicular, parallel, equal. Equal means equal length. Let's say I want them to be perpendicular. So it's going to change them so that they are now going to stay perpendicular. It's indicated by the green box there, right? Okay, great. Let's say I wanted this line and this line to be equal length. Okay, well, I can close out of that property. Now those are going to stay perpendicular. Say I want to make this one and this one. I click Control and clicked on both of those lines, and I want to make them equal length. You're going to see now that that's got a little equal sign and that's got an equal sign. So now they're equal length. All right, one more thing. Now we're going to leave it at that. All right, so let's say that's kind of the shape I want it to be, right? Cool. I'm going to now dimension it because that's if we have got these blue lines, I don't want them to be I don't want them to be blue. I want them to be black. So let's just say make this 50. Okay. It takes whatever the first dimensional unit you give it. It takes that and it makes everything kind of just like proportional to that number based on the way you've drawn it. Okay. It now seems to know exactly how long this line is. It says 45. Boom. Okay. And let's say I want this to be, let's say I want this line and this line to be equally long. Let's see if it can figure out. It figures it out. Awesome sauce. Great. Now the thing is fully defined. It knows exactly how long each line is. It knows where every line starts and where it ends. It's fully defined. It can tell that by a black outline around the whole shape. I didn't have to say what the dimensions are. The constraints I placed on it make it so that there's only one shape that satisfies all of the constraints and the dimensions I've placed on there. So sometimes, like I think actually right now, I think if I try to dimension this, it's going to give me, it might give me an error message, right? Or it gives me this thing, right? So it's like saying like, you've already kind of told me everything I want to know about this shape. So if you start to put additional constraints on it, we're going to have a problem. Basically, SOLIDWORKS takes whatever constraints you placed on a shape and says, I'm going to try to make this work mathematically. Everything you said, I'm going to try to keep it that way and make it work. Now, because I'm putting an extra constraint on here, it's asking me, do I want to make this the driving dimension, or do I want to make this driven? Meaning, like, do I want this thing I'm about to put on here to change everything else? Or do I just kind of want to walk away from this and say, you know what, I'm going to let it be driven. If it's driven, it means that everything else is making it, it's like locked into place. If I wanted to change it so that the dimension I was about to place on that was going to change everything else, then I would want to make that a driving dimension. Okay? So that's about it for That's about it for line tools. It's very similar to AutoCAD. No problem. All right, let's move on to the rectangle tool. Rectangle tool, it's got similar choices, maybe a couple of extra ones that AutoCAD didn't really have. It's got corner rectangle, center rectangle, meaning like I know where the corners are going to be, or I know where the center point is, and I'm going to have it build out from that center point. It's got a 3-point corner rectangle, which is useful. I'll show you in a second, or you can make a parallelogram. So let's just make a corner rectangle, and I want it to start here. No, I'm going to start it over here. Start it over. Let's just start it over here somewhere. Okay, and you can see it's blue. I don't know how big it is. I don't know where it is, and so in order to fully define it, I got to tell SolidWorks not only how long each side is, but where at least one of the corners is. So I'm going to say it's going to be 80 by 52, right? I don't know if that makes sense or not. That's just what I'm saying, right? And so you're like, oh, you already told it how big it is. Why is this still underdefined? Well, because it doesn't know where any of these corners are. I just randomly drew a rectangle. So here's what we can do. We can then say, all right, well, I'm going to say from this point to this point is going to be, we'll say 93. Okay? Now it knows how far away that thing is. Okay? Which is great. And then if I wanted to say, okay, from here, smart dimension, from here to here, say it's 50. We already said that. Okay. Awesome. Done. Right? It's not fully defined. It's a gray square. All right. So that's just corner rectangle, fully defined. I'm not going to fully define everything here. I'm just going to kind of just walk you through what they all do. 3-corner rectangle is just like if I know, what's a sensible way to think about this? I know let's just say I know there's a corner that's going to be here, there's a corner that's going to be here, and a corner that's going to be up there. Okay, cool. That's how you can draw a 3-corner rectangle. If I wanted to dimension it, I could dimension it and then say where the corners are. Awesome. That would allow me to dimension it and make it fully defined. Parallelogram, similar. You kind of give it a bottom corner and any 2 corners. You can kind of go click, click, and move it back and forth. You can highlight what angle you want the parallelogram corners to be. So say you wanted it to be, this to be, I don't know, 75. Okay, cool. And I wanted, what did I do? I wanted it to be, we'll make this 75. Okay, great. And I want to make this corner 50. Okay, and I want to make this side 75. Sounds great. Not fully defined yet because I haven't told it where any of these corners are. So if I just said like I want this distance to this distance to that point to be 25. Moves it over a little bit closer and whatever. I could fully define it, right? Those are your rectangle tools. I'm going to just kind of get rid of some of this. Actually, maybe I'll just zoom out a little bit. All right. Circle works very similarly to AutoCAD circle. You click, you find a starting point, click, stretch it out, and then you can dimension it, right? 3-point circles are similar. Perimeter circles, so it's like I know one corner is here, one corner is here, and one corner is going to be somewhere up here, right? Very similar. One other thing, if you wanted to do, say you wanted to make another circle in there, right? Great. If I wanted to make sure, right now, I locked it in so that this circle, actually, you know what? Let me do one thing. Let's get rid of that circle. Let me just show you something else. Say I make a circle over here, and I decide that that circle and that circle, I'm hitting the control button on both of those to select both of them. Oh, real quick. See, that's tangent. That's the tangent constraint. So no matter what that circle is going to be tangent to this one. But say I want this circle and that one circle to be coincident. If I click both those circles and click coincident, it's going to move one of the circles so that it has the same center point as another circle. So just in case you want those center points to always be locked into the same place, that's the constraint you would use. It was coincident or concentric. All right, anyway, click out of that. Arcs, center point arc, ooh, choo, choo. They work just like in AutoCAD. Tangent arc, if I said I wanted a tangent arc to be, if I highlight it, right? If I say this point, ooh, you can see how that's useful, right? I want something to be a tangent. I had this arc right here, and I wanted this arc to be tangent to it. It creates a perfectly seamless arc with it, just so you can watch it again. You can make it smaller arc, but it's still going to be like a smooth transition, right? Anything else you need to know about these guys? 3-point arc works just like an AutoCAD. Polygon tool. All right, polygon tool, similar to the AutoCAD, but a little bit different. I'll zoom out a little bit more again. Polygon tool, you select the center point, and you can see there's like a yellow polygon that's starting to be developed, right? I'm going to click again. So it allows you to choose once do you want it to be circumscribed or inscribed, just like we did in our drawing class and in AutoCAD. So if you just click it, it shows you, do you want it to be inscribed inside the polygon to be, the circle to be inside the shape or circumscribed? Cool, great. It's done. Now, I know that sometimes there were some people who were playing around with this the other day, and they were having trouble getting it fully defined, right? You know what? I'm going to take all of this. I just hit delete. I just got rid of all of it. I'm going to make a new polygon because it's just too messy. I'm going to make it too messy. So I'm going to start at the center point, make a polygon. It asks me how many sides I want. I could make it 5, 4, 3. I can make it 1,000,000, right? This one's got 10. It's a decagon. Leave it inscribed, and I say OK. And people are like, well, okay, let's make it so it's fully defined. In this case, you have to say I want each side to be, we'll say 500, whatever. And like, well, it knows the center point of this thing, and it knows it's 500. Why is it not fully defined yet? Well, it doesn't know where you want the vertices to be. They don't know if you want it to be kind of like twisted this way or twisted that way. And so you got to tell it one thing you want, right? So say like, I want this side right here. I click on one side and say, I want that one to be horizontal. Once I said I want that to be horizontal, then it's fully defined because it knows the center point, it knows the length of each side, it knows how many sides there are, so it can just mathematically calculate the angle, the interior angle right here, and it knows where to make one side horizontal or vertical or however you want to define it. So it knows where everything is. Let's see. An ellipse works like in AutoCAD. You say, okay, I got. Starting point. So you go center, edge, and then you go up or down to determine how tall you want the ellipse to be. You can also go center down and go left and right to determine how you want it. Or you can go corner or kind of diagonal and then make it like that, right? All works the same way. Center point, edge, and then click in the perpendicular direction to determine where it goes. We're not going to get into these. You can use those on your own if you want to. Sketch fillet. Let's do that. All right. So let's say I want to make a line, and I go straight up, corner, right? Say I want to make a fillet. Entities I want to fillet. That one. That one. What's my fillet I want it to be? We'll say 20. All right, that's very, very small. Say I want it to be 100. Maybe that'll show up. I don't know. All right. We will come back to that. All right. Close out of all of this stuff and F, move that back into the middle. All right, so I think we're pretty good with everything. Say I did a line, 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 and I wanted to trim just one thing. I could trim part of it just like in AutoCAD. Um, say I have a line here, and I say, you know what, I want this just to be for just for construction. If I click on it, click for construction only, you can see it changes the shape of the line. So now it's kind of like this dotted line. And now say I got like a circle and I put a circle here. Well, what if I want to mirror that? Okay, I'm going to say, yeah, I'm cool with my circle. I want to mirror the entities. Now, a lot of SolidWorks works like this, where it says, what do you, like when you go to the left side of the screen over here, it's going to like have you click on things to kind of determine and define how you want this feature to work. So I want to get rid of everything. I want to click this one, arc 8, because that's a circle. So that's the thing I want to mirror, and I want to make a copy of it. If I didn't want to make a copy, I just wanted to make it on the other side of my mirror, I would leave that unchecked, but I want to make a copy. And I click down here, and I say my mirror is going to be here. Seems like so it made a copy of this, put it over here. If I'm cool with that, I'm going to say okay, and now I got that. Okay, so mirror works the same way. Offsets work the same as in AutoCAD. My parameter will say I'm going to make it 20, and it's really small in here, really tough to see. Maybe I'll make it 150, maybe move it away a little bit. Okay, that seems cool. What if I want them on both sides? I hit bidirectional. I think a lot of this stuff is fairly self-explanatory. Is more where you play with it. Every time you finish something, you can just hit OK. And for now, I think that's about all you need to know about sketch entities. They're very similar to AutoCAD. And I think playing around with them a little bit, using the drop downs, really giving it a chance, like looking at each tool. And maybe if you want to if you just hover over stuff, it tells you what it does and how it works. SolidWorks is really good about little like pop-up instructions. So that's about it. Make sure that if I've asked you some questions, make sure you go back and answer those questions. And that's it for sketch entities. And then soon we're going to move on to taking those sketch entities and figuring out how to make three-dimensional shapes. All right, everybody. Hope you enjoyed that. Hope you got a lot out of it. And hope everything makes sense to you. That's about it for this video. All right. Closing out. Gabe Jenkins, accelerating your future. Going to see if that one sticks. All right. Thank you, everybody.